Over the last 12 years or so, I've been playing with a lot of data science, big data things, and it's very apparent to me that most museums don't believe that they hold big data. And Jonathan and I were chatting about this probably a couple of years ago and reached the conclusion that perhaps we ought to try and debunk this myth. First of all, by me telling you a little bit about what is big data, the modern terminology around big data, and then Jonathan to actually show you it in working order for his museum, the Horniman, looking at doing something real with their data using data science techniques. So in this, what we're going to do is I'm going to start off by giving you a layout of what big data is, what's the definition of it, and some of the terminology around it, and the things that you need to think about. And then I'm going to look in specific at the techniques that you need to think about when you're going to use big data, data science techniques against textual information, which after all, we have a shed load in museums. We do like a little bit of text, don't we? Right? And then Jonathan will take us through this case study of looking at a little bit of text in the context of the Horniman. So here we are introducing big data. We're going down the big data hole, and this should introduce us to it. So this is the 2011 definition of big data from McKinsey. It says big data is data whose scale, distribution, diversity, and/or timeliness require the use of new technical architectures and analytics to enable insights that unlock new sources of business value. Well, business value to us is intellectual content, the ability for us to say something more about the context of the objects that we're interested in. Now, what tends to happen is you take a definition like that and you convert it into some buzzwords. Now, big data uses the letter V. And I know you're all used to the letter E for E things like email and e-books and E by gum. And if you're an Apple head, everything's an iPhone. But yeah, for big data, everything is a V word. And they started off with 3 V words: volume, variety, and velocity. And to that, in recent times, we've added 2 new ones: veracity and value. So volume is, there is shed loads of this stuff. It's a big chunk of data, right? Variety is that it comes in lots of different formats, from free text to very structured stuff, and I'll discuss some of the levels of structuring as we go through on the next slide. So variety is all of these different ways that we store data, all of these different formats, all of these different levels of organization that we want to have in our data. And then velocity is, how quick does it move? I'm not talking about throwing it at somebody. It's how many records do we generate in a period of time. Now, we don't tend to worry about that a lot in museums because, as Hembo's just been saying, we're dead slow at creating new records. But as soon as we get into the point where we're tracking the use of our website or the movement of our visitors or a whole range of other things, we're going to be creating thousands, tens of thousands, hundreds of thousands of data points a day. So suddenly we've now got to accrete lots of new data that we want to integrate in our storylines within our institutional use of the rest of our data. So that's one kind of velocity. The other kind of velocity is the rate of change we see in the data itself. So the number of edits we do, the number of changes. So in stock control systems, how many floggle toggles have you sold? How many ABBA CDs have Amazon sold this week? That kind of stuff is a different kind of velocity. And the thing about velocity is that it requires different engineering solutions depending on which type of thing you want to do. If you want to do lots of change, you need a different engineering solution to if you want to accrete lots of new data. And we'll come back to that as we look at some of the stuff later on. So that's velocity. The fourth, the new terms, veracity, is incredibly important because most of the time big data is about dealing with data sets which are outside your own institutional walls. So we're going to bring in data from outside. And if we're bringing in data from outside, we need to know at what level of trust we are able to use that data. So there we need the metadata, which we're all talking about, and we need the paradata, which tells us how that data has been processed. Because if we don't know how the data has been processed, we don't know whether that data is now fit for purpose for our stuff. So veracity is about knowing the context of the data's creation and subsequent transformation and it landing in our laps. Final thing then is value. How useful is it to us as an institution to be tracking this data, or be doing this data, of extracting that? So the McKinsey report that I went through has just used a different set of words to say what I've just said using the V words. Right? So these V words allow us to start to talk in buzz phrases, which is great, because now you can talk to the upper classes of the museum and belabor them with nice, buzzy phrases, and they'll go, oh yeah, I've heard of that, that's great. Right? So that's useful. So let's have a little look at that variety stuff. So typically, if we're working with data scientists, they think about data at these 4 levels. So structured data is the stuff that we have in our relational databases or our RDF stores, where we have a very precise definition of what each piece of data in the set is before you read the data. So you look at it and you go, well, if I look in this field, in this table, I'll know this. That means that the first query I run, I know what's happening before the query is processed. If we contrast that with the next layer, which is incredibly difficult to read on this projector, which is semi-structured, so that's the next layer down in the pyramid. Semi-structured data is data where the structuring is embedded with the data. So this is things like XML. And there you don't know what the structure is until you finish reading the whole data set. So quite often you find that these systems work backwards. You read the whole thing in, and then you start processing arse back to head. Now, the next one was one that I really loved the phrase, and you can't see it, which is great. It's quasi-structured. And this is stuff where there is structure there, but it is so convoluted that nobody is ever going to be able to work out what's going on, right? So this is the kind of stuff you get from a web log, the logs of your web services. Because each person who's written one of the little toggles that you've got in there, one of those little mini apps that's running inside your web service, has decided in a different order of things to put in there. So you've got to deconstruct that. You can do it, but it's probably not worth the effort. But there will be nuggets in there which are incredibly easy to get at and are useful. So you can use something like regex and pull out the URLs that are in the weblogs. So quasi-structured data, we tend not to process as heavily, but we could do. And then finally, there's unstructured. So it has no structure. So text, image, either still or moving, sound, all of this stuff is stuff that we accumulate a shed load of in the museum world. And we need to learn how to process it. And there's a lot of new work being done on how to extract knowledge from that unstructured data. And that's what Jonathan's going to talk about. So here's some examples. Structured data, so this is an Excel representation of a relational database. Semi-structured, which is some rather old XML I wrote for pottery data from the British Museum. Quasi-structured, an extract from a weblog, and then me rabbiting on about the CRM in this video. All right, so a nice mixture of stuff there. Another thing that we need to deal with is data classification. So a traditional way of looking at the data and going, what sort of thing is it? So nominal is what we have a large, very large amount of in the museum world. So this is just the names of things. The vast majority of our data is nominal data. It's just a name for something, concept that we have. All of our thesauri, everything there is nominal data. Occasionally, we have ordinal data, that we have things which are ordered, so cold, chilly, normal, warm, hot, and they're transitive. So if something is chilly, we know that it is naturally cooler than something that is warm, even though there's normal in between in this example. Then we have interval data, which is numeric, where we don't have a true zero. So you can't say 20 degrees Celsius is twice as hot as 10 degrees Celsius because the zero is arbitrary. So we have very little of that in museums, except when we're doing measurements of temperature in data stores. Most of our numeric data is actually ratio data because we're counting stuff or we're measuring lengths. So there we are generally using things which have a true zero. And that includes counting things like sheep. If there are no sheep in the field, there are definitely no sheep in the field. If I have 4 sheep in the field, that's twice as many as having 2 sheep in the field. So that's it. Now, most of the techniques that we use in data science, you need to have classified your data in this way because some techniques will not work with other types of data. So you need to know which one you're using in order to select the correct technique. Otherwise, you can do some really monumentally stupid things, which makes it look as though you shouldn't have been let loose near a data science package at all. Where are we going to keep it? So most of the time, what we end up doing is using data islands. We've got data scattered all over our institution in little spreadsheets and data moles and bits and pieces everywhere. But occasionally, an institution will go big bang, and they'll pull all of the data into a data warehouse. Now, the thing about a data warehouse is that it's monumentally slow to change because there's a huge intellectual effort to take the data from individual research databases and centralize it into a common definition that works across all of the institution's different departments. So that intellectual effort automatically means that data warehouses will fossilize. Making a change is slow. I did some work with a telco in Saudi, and they were the fastest team I've ever seen alter their data warehouse, and it took 3 months. Most of the time, you're looking at 18 months, because all of the downstream processing, all your reporting, everything that comes out of your data warehouse is going to be impacted if you make a change. So you imagine changing your core data model in your institution, and all of the impact that will have, that's what data warehouses do to you. So what we use for data science is a thing called an analytics sandbox, which is basically a playground. And it means that I can create derivatives of my data. I can say, well, let's add the number of these to the number of those, divide it by the number of these, and take away the number I first thought of, and that will be my derivative. No, I don't like that. Throw it away. Now, if you did that in a data warehouse, in your main data repository, the data management team would be hunting you in the car park with a pickaxe handle. You can't do that sort of stuff. Just go, oh, let's build it. Oh, no, I don't like that. Let's do something else. Right? But in your analytics sandbox, you have permission to do precisely that. So off you go. This means that we can start to think about feeding data in from maybe a data lake, a central repository of all the data sets we own, and pushing those through into our analytics environment so that we can make really sensible analytics decisions, not having to worry about keeping it in sync with everything else, so we can be more innovative. Typically, we talk about a difference between business intelligence, so our traditional reporting, how many of these have we got, where are they, and data science, where we're looking at what will happen. So data science is about what will happen. So is this likely to be something? Is this term likely to be searched on? Is this way of organizing things for a display likely to appeal to a particular type of audience? So now we can start to project what we expect to happen. So we see decisions or questions around business intelligence, which are which pages were viewed most frequently on our website, things like that. Whereas in data science, it will be which web page will be the next web page that they'll click on. So where do I put the link to it? I put it on the opposite side of the advert for the shop, selling them a replica of the thing that they've just been looking at. Oh, horrible commercialism, fantastic. Data scientist is supposedly the sexiest job in the 21st century. You get to wrangle your data and have a whip and wear a white coat and a stripy t-shirt so you can be a pirate and use languages like R, the pirate's language. But what qualities do we want from a data scientist? So they need to have some ability to count. They need to have some ability to do a little bit of programming and deal with the technologies. They need to be severely skeptical about things. They need to be able to suck their teeth and go, that can't be right. Because the theories that are coming out of your curatorial staff are going, you need to produce the null hypotheses to test against them. That's your skeptical. You need to be able to communicate and collaborate. Can you actually talk to other people in your museum who might be a bit shy? Trying to get an archivist to talk to you is very difficult. And you need to be curious and creative. You need to look at new data sets all the time. You need to be looking at different ways of thinking about the data that you have, the data that you might have. When will it be interesting to do it? What other things can I get from outside and bring them inside the walls? Okay, so that was a whistle-stop tour of text as big data. So now I'll have a look at text as big data. So there are two big challenges with text. One is a very high dimensionality problem. So I don't know if you know green eggs and ham. Unfortunately, in our house, we know it very well. My daughter was very, very keen on this, so we'd end up reading it 20 or 30 times a day. But green eggs and ham is famous because it's written with only 50 words. There are only 50 words in it. But that makes it a 50-dimensional problem. If you look at technical English, we're up into a 170,000 dimension problem. If you go multilingual, you're into several million very, very quickly. All right? So that's the problem. And the other thing is it's unstructured. So there are a series of tasks that we'll typically want to perform. We're going to parse it. Then we'll do some search and retrieval. Then we'll do some text mining, but we're actually not going to do that in a linear fashion. We're going to bolt those together to form a solution that allows us to tackle a particular task. And that's what Jonathan's going to talk about in a moment. So how are we likely to store this? We can use techniques like this bag of words, where I take apart the text. So this is page 8 from Green Eggs and Ham. It has some words in it. I just put a countdown of the different words that I have, and I can translate that into a relational rectangular table like this. I've got the words along the top, the different references, so the different pages down the side, and where I don't have an instance of that word in a particular page, I'll have a null. This is monumentally tedious. There's a lot of nulls. If I've got 170,000 columns, most of it's going to be null. So that's pretty boring, and it also means that if I've got a lot of text, a big corpus, and I want to add in a new word, I've now got to go to every record and insert a null in it, which is rather computationally intensive. So what we do is we move to what are called column family databases, where we have a key space, which is all the possible words, in this case, that we can have. And for each particular entry, we just pick the ones that we can use, or that are used. So here we've got green occurs once on page 3, and I have a timestamp so that if I update the records, I can tell which record we're going to use. And this overcomes the different types of velocity I talked about before. This allows me to add amendments to the data into accretions of new data by adding a new record at the end with the new information in, and the timestamps tell me that that's the one I should be looking at. Examples of this are Cassandra and HBase. 10 seconds.
Do I use to go to the next slide? The big one. Okay, thank you. Obviously. Okay, quick change. Right. Right, that's how it works. Okay, so the Horniman Museum is a medium-sized museum in South London. It's got pretty mixed collections. It's got an anthropology collection, of which a large part is musical instruments. It has a large natural history collection. It also has an archive, a library, and it has living collections. So our garden is part of our collections. We have an aquarium. We've got a few alpacas and rabbits. So we think of pretty much everything in the museum as being part of our collections. The museum's about 100 years old, but we've never thought of ourselves as a place where big data might live because we're too small. That word big is really off-putting. And also, when we think of data, we've always thought of what's in our database. We've never really thought about all the other kinds of information that we had in the museum. So when Stephen started to talk to me about big data, and I started to realize that big data didn't necessarily have to be an enormous database, this was really quite an eye-opener. And I'd already started exploring things of using different kinds of data all in the same place already. So let's get to where we are. So we had a particular problem we had to solve, really common problem these days in museums. We had a new gallery called the World Gallery, just a small theme. And there'd been like 6 years of intensive research to put this gallery together. But even before that, we had all the museum's 100 years of research about its anthropology collections in particular, which went into this gallery to go into it. So inside the gallery, we had 3,000 objects in 60 cases, 40 themes, 327 text panels, which equals about 20,000 words. We had 150 images, 10 audio videos, and 5 interactives. That's not actually a lot in comparison with what the museum holds knowing about its collection. And this is a problem in even quite a medium-sized, almost big gallery like this one, if there's not a lot of room for giving information. And particularly when you try to cram 3,000 objects into it, which is quite old-fashioned, really. So all the text panels are like really small. So people wanted some of the research data to be available to audiences as well. And so this project was devised called Layered Information, and the idea was, guess what? We'll put it all on the website. But when I came into this project halfway through, or slightly after halfway through, and a lot of the concepts about what might go into that layered data had started to be formalized, but no real mechanism for how it was going to happen. So we started to think of what we might want to publish as being quite a lot of data, 7 years of work with 10 researchers. That had generated about 30,000 mostly Word documents, with awful file names, 35 document 47s, and lots of media records have been sort of gathered together, some of our own, some of other people's. I'll talk about the wiki a bit in a minute. We had the collection database, of course, initially with about 5,000 objects were considered for the things. And then we had these other reference databases like Zotero and all these other things that had information about the research that had been done. There was no kind of common structure to that. There was no common referencing throughout it. It was just the way that curators worked, which is very creative, created a beautiful gallery, fantastic learning, great object labels, but all this mass of stuff that was behind the scenes really didn't have any kind of structure whatsoever. And it obviously connected with everything that the museum had done previously, as I said, for the previous 100 years. We also included non-museum input. We really were keen to do that in this project. There wasn't a lot, but there was some. So we had some community projects that wrote text for us, drew pictures, contributed art, and those sort of things. And that doesn't stop. The gallery project didn't stop when the gallery opened. There was 2 years of funding after that for additional research and additional community things. So that felt as though it was starting to fit the big data definitions. So we definitely needed a new technique for managing this. So the first thing that we initiated was a wiki. Wikis sit quite neatly between the sort of very structured and the not so structured, because they work on links, basically. I mean, the one that we picked, you could only create a new page by creating a link. That was the only way of creating a page. So there was no unlinked pages in the whole thing. And each link, because it goes to a page, goes to a record, and that record might have a relationship with something in the real world, and tended to. So we found that very useful. And we used this to develop the gallery text in, and we also used this to start putting other users generated texts in, and we tried to encourage some of the curators to start writing generally in it, and some of them did. When I actually set the wiki up, I was suddenly whisked out of the country for a few months. When I came back, they generated hundreds of pages, which was absolutely fantastic, and they found it very easy to use. They all said the same thing, that what a relief it was not to be writing text in the collections management database. It was actually quite nice to do it in an environment where you could make bold and bullet points and all sorts of things like that. Our data set had all these Vs. There was more of it than we knew what to do with. There was lots of variety of sources. It was changing. There was both new creation and there was change. Perhaps not the greatest attribute, but it was steady. Veracity really mattered to us because we wanted to include contributions from outside, and obviously research. Veracity is at the heart of research, and our researchers very much wanted to be able to know that what they'd said and the references that they put into their research would be valued. And the value to us was that this really was what we wanted our audiences to know about when they weren't in the gallery. When you're in a gallery, you're more interested in looking at the objects than reading the text. At least most people are. Not me. I like the labels, but that's just me. The real value, it had been stated from the start of the project, was in this background research, but we didn't really have a way of getting it out there. Now, I may have given the sort of impression that this was quite an organised project, but as I said, I came in very late to it, and we met the most useful of research tools, blind panic. And I was literally having cold sweats about how we were going to deliver this in a timely way, with just basically me working on it as well. And I remembered on the train one morning that a few years earlier, I had been introduced to text engineering at Sheffield University through a tool that they've called Gate. And Gate is lots of the things that Stephen was talking about. So it's an analytical environment. It sucks in loads of text in loads of formats, and it allows you to process them, but it also allows you to change them without damaging the original source. And it breaks things up into those words that we saw from the green eggs and hams, and it does a bit more than that. It really easily breaks it up into parts of speech, so it tokenizes, lemmatizes, does all these things really simply, and allows you to do text engineering tasks. And I thought that perhaps the structure we could apply would be to find common terms throughout that great big corpora of research and use that as a kind of a structure that would allow us to navigate and to analyze the body. And that when we put it out there, we wouldn't have to hopefully it would find references to objects in the collection. That was the main thing I was looking for. That every time they'd used an accession number or a sort of given name, like the Horniman walrus is a name that gets used for a particular object, or this sword or that text. These things have names as well as having identifiers. And it was going to go and look for all those kinds of things and find them. A bit like this. And the idea was that we'd link them up. So we'd have blocks of text, and they would recognize that and the text engineering would find and create relationships between the reference terms that were already in our collections database. That was as far as my early thinking went, was that would give a bit of text. So this is the kind of pipeline that you can build in Gate. Basically, it goes through and strips out everything you've done before, because that's important. And then it tokenizes, so it goes through and finds what's the word boundaries, finds where a sentence begins and ends. It does parts of speech tagging. And then we exported all of our terminology out of the collections database and turned them into gazetteers, just lists with attributes. And then we ran through those, and then we used a transducer at the end to sort of clean it up and go and find to get rid of sort of hanging terms and all sorts of things. I haven't got time to go into JAPE, but it's regex for JSON documents, and it's really cool. And so that's what we did, and we ran that over all these blur of documents that we'd ingested, and we got some pretty good hits, and we did find some sort of common terminology, and we also wrote some other scripts that turned those back into wiki pages. Then we built a publishing mechanism so that those wiki pages could go straight to our website. But it wasn't quite accurate enough to not need checking, because although it was doing more than just entity recognition, it was doing a bit of lemmatizing, it was finding the different parts of the speech, it wasn't really doing enough to stock check. We also ran it over some of the non-museum text and found some quite sort of interesting other words that we might want to put forward. So, have I gone past machine learning? Have I whisked past machine learning? No, I haven't. There it is. There. Okay, so it's because there's two slides on the screen. I'm not used to this. Okay, so we decided that in order to make it more accurate, we needed something cleverer than me. So a machine, basically. Machine learning is really interesting, and it goes and looks for patterns, and then if you tell it some rules that are associated with those patterns, it goes and finds much more subtle patterns than we're ever going to notice, and starts to apply those rules, and you get a sort of suggestion of things that it spits out, and you can say, oh, that's good, oh, that's not so good, and you can relearn. You can do it as a sort of iterative process. Well, we found that over just 2 iterations, we upped our accuracy. There are two kinds of accuracy, but I'm just going to use an overarching term, from somewhere around 60% to up to 89, 90%. Now, I've done a previous presentation demonstrating and proving that humans are 11% inaccurate. So anything that gets above, I'll do that again sometime if you like. But that's it. Humans 11% wrong. Therefore, any machine that gets up to that sort of level is doing really well, and that's as good as stuff that we put out. And so we were happy with that, and we started to put texts out that had been marked up by the machine learning without us even checking it. Not very many, but we did a few. And then we ran, then we started thinking about, well, what else can this do? Well, we wanted to start to develop new terminologies. So we started to run it over other texts and stopped and threw away the gazetteers and started to say, well, what other words have we used that we don't have in our gazetteers? And the machine learning showed us quite a lot of those, so we created new terminology, created new knowledge. And we also ran it over the few bits without the gazetteers, over some of the text that we had from user-generated content. Didn't work brilliantly because we didn't have enough. We just don't really have a big enough corpora of that. If I've got time, I don't think I'm going to have time. I'll tell you about another project that we're doing that's going to talk about that. So, hobby horse alert. I've always worried about the fact that computers have over-structuralized museum content. Museums love structure these days, and computers have just been like catnip or crack cocaine for the structuralists in museums, and taken us down a sort of structural path, very popular. I like text, I like stories, I like verbal stuff, I like pictures. And I've always worried that they've gone a bit sort of second-hand in data. What this does is allows us to use both together. We also are now keen, a bit late in the day, but we are now keen to decolonize and democratize our collections. Got there in the end, maybe, started. And this is something that Horniman's been very keen on, but actually for slightly longer than some people, only slightly. We are working at the moment with, we have a project with some African institutions and some African diaspora communities to start maybe using this sort of technique over corpora that they've developed in order to start generating new terminologies that could be reapplied to our collections. And that gives us the opportunity to use terminology that is common to both others and museums, or just others, or just the museum, and to really kind of color code that. I mean, you can flag it up and you can say, look, this link's a museum link, this is a link from the community, and this is one that we agree about, or something like that. I mean, there's all sorts of ideas you could do from that. I'm always quite keen to throw class into the decolonization idea as well, because I'm English and we have a lot of class. If you're not from England, that picture probably doesn't mean a lot to you, but okay, I've gone into question time, but really the main point I'd like to make is that, as Steve was hinting at, museums do have big data, even if you're a little museum, because we've got the wide variety of museum, and that the techniques that big data opens the gateway to are really good for museums because of the messiness and complexity of museum data, and also because it gives the opportunity to include really diverse documents, but also diverse voices for the same reason. There. Oh, okay.
Thank you. Do we have any questions from the audience here? Everything is crystal clear, obviously, because of the very good deductive slides you had in the beginning about parameters of big data. In the session before lunch, we saw some examples how images were also analyzed next to text that came out of a museum using similar tools. If not, then we're all ready for coffee. Oh, there is a question there. Miga.
No, he's just scratching his head.
The mic was so close. I think there was a small contradiction here, because you said that text has no structure, but I think you proved yourself that there is really structure in text. And I have been working with this, and I have come up with an idea of a hidden grid. And the hidden grid is really in our brains, and that enables us to communicate with each other. And the hidden grid is manifested in grammars and in text. So and that enables you to derive something with the means you used from text. So text is really valuable in that and useful. And in addition, I just want to thank you for this presentation, both of you. It was like listening to a symphony. I enjoyed it very much. Thank you.
Thanks, Lee.
Thank you for this. And we're now ready for coffee then. Thank you.